this panel started. We have two fantastic panels coming up. This one is startups, and then the next one will be about venture capital, so I want to stay on time. We are really fortunate to have here four founders of data science startups. Now, they are in a long tradition of startups coming out of Berkeley. When I started doing research about Silicon Valley, I was aware very early on that Berkeley was a source of startups, as well as that one down on the peninsula. And this continues. You know, the Silicon Valley, one of the things about the valley is that it's been it goes through cyclical periods. It goes through booms and busts, and the booms are usually associated with waves of new startups. Waves of new startups, usually in sort of a sector. You know, there was a wave of startups in the late 80s and early 90s on application-specific ICs. And then there was startups, I remember there was a wave of disk drive startups. And everybody looked and said, this is the most inefficient ecosystem ever. Why do we have 25 different companies funded to do disk drives? And it turns out that that is a very useful pattern, because while there's a lot of redundancy initially, this seeds out what is the best technology, who are the best managers, what is the best pathway to take. And those people recycle themselves and come back and start new startups. And then you go through sort of a recession and then a new wave. And obviously, just by the fact that this room is so full, we are in another boom. And it is the data boom, the data science boom. And I wanted to showcase the work of Berkeley startups. So I have here, to my right, Joe Hellerstein, Jan Stoica, Kwang Chen, and Josh Bloom. And I'm going to start out by asking them to say a bit, each to say a bit about where they came from, how their company got started, what piece of the stack are they addressing, and then what specific problem their company is trying to address. So Josh, why don't you start?
Great. So I'm a professor here at Berkeley in the astronomy department, and sort of stumbled upon machine learning as a way to do great and novel science that we wouldn't be able to do by other means, sort of recognizing that while we were getting more and more data, the traditional way to deal with that was to hire more grad students to look at the data, and so recognize something had to change. So we sort of cut our chops and had some great successes, recognizing that we weren't just doing machine learning for machine learning's sake, but we were doing it in service of something that couldn't be done by other means. And that was really the genesis of the company. The company actually started in this room, which probably you didn't know. It was sort of sitting right around where Ray is sitting. And it was at a conference that my group put on, basically called Streaming Insight with Machine Learning on Big Data, and this was about 2 years ago. And there was this amazing thing that happened at the end of each person's talk. Said, well, yes, somebody was working in the biological domain, somebody was working on EKGs, and all of them were saying, basically, I tried all these different algorithms, and this thing called random forest wound up doing the best for me. And that happened to be the one that we had already hit upon. It was also where our IP was in our nascent company. So we decided actually that week, which was essentially 2 years ago this week, to start our company. It's called Wise.io, and we've evolved quite a bit from selling IT tools and platforms to data science teams, and now we're selling directly to business users with applications that are specifically tuned towards solving a pretty important problem, and that is you have customer-facing folks in businesses that are getting more and more data and don't have the tools that they need to be predictive with that data to extract the most insight out of it. So we're essentially selling applications that sit on top of SaaS-based data sources. So for an example, one of the ones that we sell sits on top of something called Zendesk, which allows people to be more efficient with how they respond to people's trouble tickets. And it's enabling customer support folks at the VP level and director level to really make their whole operation more efficient. And so one of the important lessons I think we'll see in the panel in lots of different ways is that obviously finding the right buyer of a data science activity is a critical one, and making it very useful for them and showing them the value right away is really what they're looking for. No one's really looking for tools. Tools are always just the thing that you use to get to something, to get to real value.
Thanks, Josh. OK, Kwang.
Hi, my name is Kwang Chen. I am the founder of Captricity. So I started out here in 2007 as a PhD student, actually Joe's PhD student. And I remember early in my career, I walked into Joe's office and I said, I want to use, what did I say, data integration to help poor people. And Joe was incredibly supportive, if not maybe somewhat confused by this guy in front of him. And fast forward quite a few years later, we've had a lot of fun, and I've gone off to some neat places like Tanzania and Uganda where we really did basically do just that. But I didn't find that it was really about analysis in places like a rural health clinic where they needed the most amount of help. For data to be valid and useful, they just need to have it in the first place. And so I wound up working on data entry and in efforts to make it go faster, make it more accurate, and ultimately replace the need to do it at all. And I think the third project that we tried got some traction and became eventually Captricity. And so what Captricity is based on is this concept that you can use commodity cloud computing and crowdsourcing combined together to dynamically train learning algorithms that do better at OCR than OCR can ever do by itself. And the moment where we realized that this might be a company and not just a neat tool for international development was when I realized that the existing companies in the space basically will require an organization to spend millions of dollars to buy client-server software to do OCR, and then you have to hire people to type it in. And in the context where we were working, where there's solar-powered electronic medical record systems, there are such things. It's just that's not a possibility at all. And so we really set out to make this type of technology accessible to any level of organization. And today, 3 years later, we're in about 300 paying customers, and they range from those types of clinic level, a lot of international development organizations, but also folks like the Food and Drug Administration. And the work we do for them is actually quite related because we realize that we're essentially doing public health, but here, and it's really nice to make that connection because at the end of the day, we're essentially enabling public servants to do more with their data and to help lift that data out of paper into something that their analysts can actually use.
Great, thanks so much. Okay, Jan, remember, make it in English that people can understand.
So, my name is Stoica. I'm a faculty at Computer Science Department here. And I've been part of these labs, Computer Science, Rad Lab, and now AM Lab. And 6-7 years ago, we started working in this kind of nascent space of big data processing systems, the emerging ones, like Hadoop, MapReduce, and so forth. And for like 1-2 years, we tried in this ecosystem to improve some of the tools and so forth. And then, like 4.5 years ago, almost 5, so we started to build actually, once we learned kind of what are the limitations of the existing systems, to build our entire stack. And it was starting with all the way from resource management, data processing, and various libraries targeted for different workloads, including machine learning, graph computation, and so forth. And one of the key components of this stack was this cluster computing engine called Spark. And we started in 2009. It was released open source in 2010. And in time, it became quite popular. And it being adopted by different users and to have a lot of contributors from the open source. And then in order to sustain that evolution, we started a company last year. So we are still very early on. We are still actually in stealth mode. and since then, it was a pretty good decision, at least from the point of view of the open source. Now Spark is really adopted widely. It's in the distribution of every, it's included in every Hadoop, well, major Hadoop distribution. And in terms of contributors, it's extremely popular, even more popular than many of the Hadoop projects, actually all of the Hadoop projects. So, and really what problems it solves, why did we do that? So fundamentally, when we started, we focused on some of things that Hadoop was not very good at, right? Hadoop was, doing huge scale computation on massive data on commodity servers and tolerating failures. So it was fantastic for that, but then it wasn't that great for doing this more iterative computation, which is required by algorithms like machine learning and graph-based algorithms. It wasn't good for more interactive queries. So that's what we built our solution to address these usage scenarios. And as the basis of it is also to more efficiently and aggressively use of the memory while still providing fault tolerance. So that's mostly what the company we founded. It's called Databricks, and it's downtown Berkeley. That's about it.
Thank you very much. Joe.
My name is Joe Hellerstein. I'm also a computer science professor here at Berkeley. And I've been doing data management systems since I was in college, actually. My first job out of college was at IBM Research, one of the two birthplaces of the relational database. Then I came to Berkeley, the other birthplace of the relational database, to do a master's. And after that, to Wisconsin, which is sort of the third nexus of database history. And then I came back to Berkeley on the faculty in '95. So my background's very much in the systems behind data management. And over the years in the '90s, I got interested in topics that connected user experience, statistics, and data management systems together in order to provide interactive behaviors with long-running jobs and databases. And so I took an interest at that time in this nexus between stat and big data systems and user experience. But there was no one really here at Berkeley at the time that was interested in data visualization or data interaction models. And so it took a number of years before I had the right colleagues together to work on this problem. And sometime in around the late 2000s, 2007, 2008, my colleague Manish Agrawala was here. He had a superstar student named Jeff Hare who had graduated and gone on to Stanford. And Tapan Parikh had joined at the iSchool. And I had these three friends, colleagues, who were working in human-computer interaction, who I just respected the hell out of. And so I gathered them together and we started a research project called Data to the People. And it was just a little kind of coalition project. We didn't raise any funds, we didn't build a lab. We just would get together with our students every week. And because Jeff was at Stanford, we'd meet in San Francisco. Adobe hosted us for a lot of these meetings. And we would talk about problems that were sort of human-computer interaction problems around data. And the reason I got so interested in this recently is because with Moore's law, computers are so cheap, storage is so cheap. At some level, people like Spark and Hadoop are upending the software industry as well. So software is actually becoming really, really cheap. And these are all at some level commoditizing. All that stuff that was my unique superpower in the '90s as being a back-end guy just didn't seem to be valued at some level because we'd done that stuff, which is great. And what was clear to me was that the bottleneck in computing, especially around data, was with people. And that we had to take technologies and address human efficiency problems rather than computer efficiency problems. And so we gathered up this team, a really superstar team of people. Those guys are just amazing. And we started looking at the full data pipeline from data acquisition through sort of data transformation and cleaning, analysis, and then visualization and collaboration, which is, by the way, never a straight line workflow. There's always all these loopbacks, which is something we talk about all the time. Out of that project, we have two startups, so Captricity and Trifacta, which is the name of my company, as well as an open source package called MADlib that's widely used for machine learning at large scale in parallel database systems. So it's been a very successful project, although we don't talk about data to the people all that much. Trifacta took on the piece of the pipeline that was around the data transformation problem. And a piece of the research we did along the way, Sean Kandel was the grad student on this project. He was at Stanford, so Jeff and I co-advised him. And as part of his research, he went out to actually do a user study about how do analysts spend their time. If, after all, this project was about making analysts more efficient, well then, where are their inefficiencies? I'm a software guy, so I tend to write code and run experiments and prove theorems and stuff. But these guys go talk to people and do social science. And so it's great. So Sean went out and he spoke to 35 analysts at 25 companies. And he wrote a very lovely survey, which you can go find. Google for Kandel, K-A-N-D-E-L, VAST, V-A-S-T. And he has a survey in the VAST conference on how data analysts report that they spend their time. And it was eminently clear from that research that analysts were reporting spending most of their time on data cleaning, data transformation, data wrangling, data munging. They had all these words, but there was clearly a gap in the software space. And if we were going to try to use technology to solve human problems, that was the best place to start. And Sean had built a tool called Data Wrangler, which is still live on the web, actually. You can use it. It's a data cleaning tool and a data assessment tool. And it was a very small scale tool. You had to, it could wrangle as much data as you could paste into your web browser. So, really big data, hundreds of rows. But it can take really messy data and very interactively transform it into structured data. And people like to say, that algorithms and systems like their data to be square. Right? It should have rows and columns. It should either be a matrix or a table. And if you can't get to that form, you don't have analyzable data. And then even when you're in that form, in my experience consulting with relational database companies who do have square data, there's often a whole lot of restructuring and data cleaning that you still need to do. And so we went out and we raised money from some of the people you'll meet in the next panel, who I see in the back of the room. Thanks, guys. A couple years ago to begin the company. And we've been building it for the last 2 years. We're located in downtown San Francisco, right off BART, which makes for a nice commute from me from the East Bay. And we delivered our first product in February. We're starting to get good feedback from the market as to how people are using it. I'll give you one scenario. Folks at Lockheed Martin using the software to work with actually healthcare data as well for the federal government report that things that used to take them 6 weeks now take them a day. And what I like to talk about is particularly when you look at problems that are human-facing, is when you take a quantitative change, so something you can measure in time or in resources, it becomes a qualitative change. It's such a big change that you behave differently, that you can do different things. I think some of the shifts that Jan was alluding to between batch processing and interactive processing, sort of at the back end, are related to this. It really changes the way that data scientists and data people think about what problems can I address with data? How will I spend my time? How will I allocate time between kind of the messy business of doing data and the interesting business of applying that data to real problems? And so we're beginning to see that as the company's coming out of the gate. It's very exciting.
Thanks, Joe. And those of you that were here at DataEDGE last year saw Jeff here do a fantastic presentation on some of the tools that you've developed. So about a third of the audience here is students from the iSchool, including the students in our Masters of Information and Data Science, our new program. And they are being educated to become data scientists. So I figured I would ask all of you to make a comment on what data science work or analyst work will look like in 5 years, given that we're seeing this explosion of tools and new technologies that make their work easier. So you want to start again, Josh?
Yeah, so maybe I'll start off with something somewhat controversial as a statement and say that I don't think there is such a thing as a data scientist.
Yes.
I think a data scientist is a unicorn in the following sense. When we talk about what data science is as a discipline, we talk about it as somebody who needs a PhD in physical domain if we're talking about doing science, or an MBA who can articulate a business problem. Somebody who has deep stats training and computer science can look at an n-squared algorithm and log-nify it in their sleep. And somebody who's great at the back end, who can hack, who can write a Julia interface to Spark. And we ask that to be in that one person. And I think we've essentially there just defined the null set of unicorns. But I do believe very strongly in the concept of data science. That is, that there is something very special about bringing all of those people together. And we can't all be ninjas at all of these different things. I think at best we can become very, very good at something that we're known for in this realm and be conversant and perhaps even somewhat fluent in some of these other tools and techniques, but recognize in the people that we work with what their challenges are and be able to articulate what we're good at, understand what they're good at, and build sort of great solutions together. The way I sort of think about it is, Michael Jordan was the Michael Jordan of basketball, but he was a pretty mediocre baseball player. And so if we were asking one person to be that star in so many different realms, I think it's very dangerous. So when I think ahead to where we're going to be in the next 5 years, first of all, there is this boom, and it's very helpful for raising money and for getting people to come in your door and be excited about what you do, this term data science and big data. But there's also the trough of disillusionment, which is either now arrived or coming. And on the other side of that, I think we're going to wind up seeing that this is a real thing. And that the people that are doing well are the ones that work very functionally in teams. Yeah. And in part, what you heard in Joe's introduction was his discussion about the importance of people in his work life and in his path. And I think you need to see that on a daily basis. So what I think will happen, and this could be a danger for this sort of SMB market at some level, is that it's going to be very hard for companies of moderate size to hire a data scientist. In a sense that while this is starting to happen now, oh, I've gotten too much data, now I better hire somebody who's going to help me with that. In the end, what happens is you wind up seeing these people get quite disillusioned because they are walking around with sharp elbows, trying to gain access to the different data sets to bring them all together, to try to articulate the answers that they're getting to the people above them in the ladder, and then being asked to sort of put this into production. So I think the only way that data science will survive throughout the sort of the big part of the economy, the long tail of the economy, is going to be when we figure out ways to get people working in teams.
And Michael's talk this morning was all about data science teams in the wild. So thank you so much. Kwang, how are things going to be different in 5 years?
Let's see, in 5 years. So I like to bring up the concept of the value per bit in data. And the first thing that came to mind as Josh was talking was this somewhat silly conversation that I had with the CIO team, or maybe a analyst team at a large corporation who really wanted to do data science. And they were talking about all these big tools, rather tools that could handle large volumes of data, and they were just totally stumped as to what data sets they had internally that could justify the purchase of such a tool. And over some time, we started talking about logs. Machine-generated logs definitely generate a lot of data, maybe to the volume where it can't fit in memory in one machine. And so you would want to distribute that, and you would need sort of these modern tools that the biggest companies would need to implement in order to analyze those data sets. But what I took away from that conversation was that instead of looking at roughly data exhaust, I think people should be not focused so much on the tools, but on the data itself, and ask what data in your organization has the most value per bit. It just so happens, in a self-serving way, the highest value data is stuff that people bothered to write down. And they might have written it down and filed it away in a file cabinet. And if we could unearth that is just, it's one small aspect of what the future could be. We have this really neat project going on with a police department in a large city where they have an extended version of a domestic violence report that they make all the beat cops fill out. And in a year, they gather about 140,000 cases worth. And roughly, because it's paper, they just file it away on the shelf and never to be reviewed again. And somebody at the top said, hey, there's great value here. Can we, and I think you can this is sort of the Twitter version of the project, but can we moneyball this, right? Can we apply predictive analytics with the same level of attention and care that we apply to something like baseball, to something that's truly important, like domestic violence in a major metropolitan city here? And the results aren't out yet, but they are using Captricity to build a nice square data set out of handwritten forms so that some real data scientists can put their tools to use. And I'll end with a thought that the Chief Health Information Officer at the FDA does both sort of large-scale data science as well as do things like use Captricity for their forms.
Yeah, thank you.
And he said, the best data science tools don't matter if you can't get to the data in the first place.
Yeah. Great.
I just wanted to kind of riff off of that for 1 second. What I heard in one sense is that there's a lot of value in small data. And we sort of lose the fact when we do use these buzzwords around big data that there's a lot of value in Excel spreadsheets and in just human exhaust. But in thinking about where this all goes, obviously there'll be more and more of the human exhaust. But I wonder, with this, again, another buzzword, sorry, Internet of Things, the idea that while it may be very small amount of value per bit, there will be more data generated by machines than will be the exhaust and the output of people. And we're sort of seeing the interface of that happening, with around the wearables. It's still sort of related to people activities, but it's still sort of sensor-based data. So in 5 years from now, I think the data sets that will be taxing, the next generation of the Berkeley analytics stack may not be the data that's, this sort of nice generated data by people, but will be generated by machines. And we should be sort of keeping that in mind, I think, as we're thinking about new tools.
Great addition, yeah.
So I think I want to point out 3 things. So the first one is that today we are at this kind of interesting juncture in time in which we do have this great example of super successful companies who are based on mining the data, like Google, Facebook, Twitter, and so forth. So you have these aspirational examples. And then, on the other hand, today, because data is so easy to store and so cheap, then you have almost every company just storing a lot of data. And of course, the reason they store this data is because they want to bring the value out of the data. And again, they have in their minds these aspirational examples. And again, they want to improve their revenue, reduce cost, whatever. But it's a huge gap. And this process of going from the data, which was actually everyone on this panel emphasized so far, there's a gap between having the data and extracting the value out of the data. It's huge. And it's a hard problem. And in order to convince yourself that it's a hard problem, you should just ask how much money it's Google or Facebook of the world spending on systems and tools and applications to process this data. It's billions every year. So I think that in the next 5 years, you are going to see more of technologies which are going to bridge this gap. So what this means is that it's going to empower more people to be more efficient in processing the data and extracting this mythical value out of it. So that's number one. The number two, as you look at the entire pipeline, in many cases you have this pattern. You have some set of data, then people using some tools, data scientists or data engineers, use some tools to mine the data, and then based on that insights from the data, they are going to make some decisions. Because fundamentally, unless you make a decision which will have an impact on the bottom line of the company, the value of that process is not that high. And you want to get into that. But I think that in some cases over the next 5 years, you'll see that in easier cases, you'll see that instead of this being a manual process, it will be more automatic process. Like, for instance, just give you an example, like today, maybe if you are watching MLB or something like that, online video, when something happens, you know, something goes down, like, or you have a massive failure, typically now what happens is that you have someone, a human, which notices that and then reroutes the traffic or rebalance it. You know, that's clearly one thing which is easy is going to be automatic, more and more automatic. And the last point is that about going back, I'm going to take Josh on this unicorn data scientist. I would like to, you know, for people again to think about maybe how was a computer scientist. Yeah. So probably in 60s, if you think about it, was that person should know a little bit of electrical engineering, math, and so forth. But eventually, you know, computer science became a pretty successful field. So, you know, let's see. Maybe this is harder, maybe this is different. But it's very, very early.
So are you a great electronics person right now? Again, I think it's the same thing. You can be part of a computer science department, and you have great talents if we're talking about an academic realm.
It's again, you always specialize. The question is that it's going to be a discipline, which we have a discipline, data science, right? The guy who is, or the person who is doing that, how we are going to call that person.
We're not going to resolve this today. We've made a bet. We've made a bet that there's a field, but they will be in teams. They will not all be specialists in visualization or analytics or whatever. They have to specialize. So I think you're both right. And now, Joe.
I mean, clearly they're both wrong. That's fine. Get three professors in a room. So, in brief, how will data science change in 5 years? I think Jan alluded to it in the same way that I think computing changed over the last decade, or maybe 2 decades. Used to require people with really big glasses and lab coats to operate computers. Now everybody's got a computer in their pocket. We're still operating data, essentially, with the guys in the lab coats or the people in the lab coats, women. And that clearly has to change for this to spread and grow and be a thing. So the way we look at it at Trifacta is when you get up in the morning, if you're a professional data person, what software do you turn on when you get to your desk? The answer is very unclear, mostly because most of the tools out there are god-awful. They're just absolutely terrible. And in particular, almost nobody is thinking about the user experience around working with data and what are the particulars of the tasks that data people do. So our ambition in 5 years is to fundamentally change that and to make data science something that, first of all, many people can do to a degree, so it's very accessible. And secondarily, people who are very technical are using their technical skills for the hard stuff and the interesting stuff and not spending their time doing what should be automatable or semi-automatable. And so you want to get that engagement between the computer and the data and the user to be very efficient so that the user's input to the process is around their domain knowledge. So what do they know about the problem they're solving? That they need to input, that doesn't get automated, right? And then also for the sophisticated users around what methods and how to parameterize them and all those sorts of things. So that would be what my ambition for what to change in the next 5 years is exactly that.
Well, and that fits very well with the discussion we had earlier about the way that the tools are not only hard to use, but don't fit together. And so, good. I'm glad that somebody's working on these problems. I'd like to open this up to the audience to see if you have questions for our panelists. And I think there are people with mics who can, we have a question right here.
This is a terrific panel. Thank you very much. Joe, my question is for you. You started down a path in your initial comments where you talked about how data wants to be square. And then you didn't follow on with that, but you absolutely had my attention. So the question I have for you is, has Trifacta changed that? Are you working with prototypes that do not arrange data in matrices?
Oh, for certain. Yeah. I mean, most data doesn't come out square. Typically from where it's generated. And it also comes out full of errors and all inconsistencies and all kinds of things that it needs to be, manipulated. I mean, there's a reason people spend 80% of their time on this. It's because it happens all the time and it's very particular. Every case seems to be a little bit different. It's not something that an algorithm just goes and solves in general. And so data comes in all kinds of crazy ways. And typically, the task of the analyst is very first off to get out something interesting from that data that they can analyze. It's the analysis tools that want squareness. It's not the data generation tools. And so that bridging absolutely is stuff we're working on. That's the core of, I think, the problem.
Great.
Thank you.
Other questions? Yeah, there's one back there.
So I hear a lot of questions on what data science is, how data science is being done, how that's going to change. And I'm kind of curious if I could ask the question of what is data science going to deliver? Like in the next 5 years, what are the most aggressive applications that you think data science is going to make possible?
So, I think it is a pretty exciting time in the sense that I don't think any one of us, if we were just going to blurt it out, would wind up agreeing what sort of the killer app is on that. I'll give you an example of something that my company did early on, which I think is pretty transformative. It was enabled by building this data science workflow. There's a company, an oil and gas safety company, that was essentially looking at pipeline health. And this is a serious issue in this country. I think the median age of pipeline is about 70 years, and it's decaying very quickly. It took their analysts about 6 months to look at about a terabyte of data, and we built this machine that could do it and learn off of the past history from what the analysts had said in about 20 minutes. So using Spark. And so what's transformative about that is it changes an industry that's been around for almost a century, where there is this deep assumption that people with deep domain knowledge have to be looking at data to make insight. And here you go, being able to basically rip up pipe that's underneath towns that could explode in those 6 months when you're actually analyzing it. There are actually some examples of where that happened, where pipes had been looked at with robots, and then while they were analyzing the data, the pipes exploded. That's just one. You just take any industry where there's more and more data, and you look at the inefficiencies of having people in a real-time workflow of that data, and you just start to be able to get stars in your eyes. Literally, as an astronomer, I say that a lot. I'm curious to hear what you guys have to say, but I think this is really just the beginning of that. And the challenge of companies like ours is to either enable others to surface those applications directly to those that need it, or build them ourselves.
I think enablement is the key point here. My other PhD advisor, Tapan Parikh, who is a professor here in the high school, likes to say that data, or rather technology, can only magnify the intent of an organization and an individual. And with data science, I think the same applies, that we get to choose what we apply it to, and the target of that application essentially gets what would be the equivalent of the best expert behavior applied on a case-by-case basis, so that there is some fairness. So if a pipeline expert can be sent out to inspect something, great, that section of the pipeline is in great shape. So then if by learning and prediction and the scaling out, you can then enable that smartness to happen on every section of the pipeline, then that's the leverage that technology and data science can bring. I leave you with another thought, which is, why don't we think, when we look at something like the debacle at the Veterans Affairs over claims, where veterans come back and they're waiting for their claims and their medical benefits for years, I don't think anyone in the room can look at the VA and say that, well, data science is going to help them, because it just seems like they're so far back. But I think that's the promise, is that every organization and all over the world can tap into the promise and the leverage that this, the technologies that we're working on here in this room can bring to the table.
Okay, we have time for one last question. I'm sorry, I know there are a lot of questions in the room, but we're running out of time. Okay, it's here.
Hi, thank you for that awesome panel, and I'll keep this question short because I know we're running out of time. So there are a lot of great initiatives around brain. There's a Blue Brain project, there's tons of data being generated by research institutions all around about molecular functioning of the brain. There's tons of studies done in psychology that generate different kind of data about behavior that's related to the brain. So how do you visualize data science informing or being able to help develop a computational model of the brain in the next, I don't know, 5, 50, I don't know how many years that will be?
Anybody want to take that one? You don't have any.
I mean, maybe we can turn it around and say, what roles do you think data scientists aren't already playing in that? To me, I don't know much about the latest developments, but it's such an important initiative and is actually reasonably now well-funded that I think the experts from the engineering perspective and then also from the biological perspective are actually getting together. I think from a research sense, that's actually functioning quite well, that endeavor. Unlike, when we're talking about the VA being way behind in just looking at their own data. So I think that might be one of the examples of where you've already got a nice confluence of computer scientists, statisticians, neuroscientists, et cetera, working on it. I don't think I know enough about what isn't working well to give you a great answer after that.
I'll give you just one anecdote, and I haven't worked with these people, but I've spent a little time with them when I was on sabbatical. There's this Connectome project that's trying to figure out the topological relationships between neurons in the brain, really just map the brain. That's just beginning. Okay, so their ability to do that is really still in its very early stages. So at some level, we're still doing sensing there. The data hasn't been gathered. Having that structural information might help with other things where they're taking other kinds of readings from the brain. But I think, and that is an effort in some sense in data science because it's a lot of computer vision and imaging technology. But it's obviously such a rich source of information that we understand so poorly. There's a lot to be done. But the thing I would want to emphasize, I think any computer scientist who's been around long enough is a little cautious. I think all of us sort of took a moment when you asked the question. Cautious about getting too excited about modeling the brain because of just the history of AI. And so what I would just say is that whenever you're thinking about doing any data science task, this one in particular, there's a what for question that should be connected to it. And so I think medical applications, for example, might not need to know everything that the brain does to be able to be helpful. So context is very important.
Thank you. That comment really wraps in nicely with the conversation we had earlier. And I want to say thank you so much to the panelists. This was a great conversation.
Thank you.
Thanks. Thank you.